Hey guys, and welcome to one last video lecture for week 7. In this one, I'm going to be talking about some of the variables that affect operant conditioning. Now, the last 8 pages or so of your reading assignment in the textbook for this week are also devoted to a discussion of those variables, and I won't be covering all of them in this video lecture, but I will spend some time on a few of them, and most of the variables that I'll be sort of glossing over here are fairly obvious ones anyway, like these that I've listed on this slide. So, one variable that obviously influences how effective a particular reinforcer is would be how soon it occurs after the behavior that produces it, right? How much contiguity is there between that behavior and that reinforcer? And generally speaking, the more immediate the reinforcer is, the more contiguous it is with the behavior, the greater the impact it has on the strength of that behavior, the better it reinforces that behavior, in other words. Now, people and animals can learn to perform behaviors that result in delayed reinforcers, but it takes longer. It isn't as efficient as a way to learn because other behaviors that occur during the delay wind up being more contiguous with the reinforcer than the behavior that actually produced that reinforcer is. So, immediate reinforcers tend to be more effective than delayed ones, and that's fairly obvious. So, the contiguity between the behavior and the reinforcer matters. Another fairly obvious variable is the size of the reinforcer, the magnitude of it, the amount of it that occurs as a consequence of the behavior. And not surprisingly, bigger reinforcers do tend to be more effective than smaller ones. Now, there are diminishing returns with that. As you increase the size of the reinforcer, you don't get a linear increase in how effective it is. But in general, yeah, bigger reinforcers tend to be more effective reinforcers. Again, that's pretty intuitive. And one more variable like that involves the qualitative differences that can exist between reinforcers. Those qualitative differences can also influence the effectiveness of a reinforcer. I mean, people and animals do simply prefer some reinforcers over others. For example, there's an interesting study described on page 147 of your textbook about how rats prefer bread and milk over sunflower seeds. So they'll run through a maze faster if they get bread and milk at the end of it than they will if they get an equivalent amount of sunflower seeds. And of course, the same thing applies to people. People are the same way. I mean, if I want to reinforce my son for something, an ice cream sandwich is a pretty good choice. With my daughter, a cookie or a piece of chocolate would probably work better. And so those qualitative differences between reinforcers do matter. And so, especially in applied settings, like when you're working with a special needs kid, for example, and you're trying to get them to do things like take care of themselves or do their schoolwork or respect others or whatever, it's often worthwhile to sort of experiment with different reinforcers, reinforcers that differ from each other in more qualitative rather than quantitative ways, so that you can see what that person seems to prefer and what's going to be most effective for them. Okay, so again, those are all fairly obvious, fairly intuitive variables that can affect operant conditioning. And there are several other variables that are described in your textbook, but in the rest of this video lecture, I want to focus on 3 more variables that aren't quite as obvious as those ones that I just mentioned. First of all, the contingency between the behavior and the consequence is very important. So by now, I hope the concept of a contingency is familiar to you. But remember, a contingency exists between 2 events if the occurrence of one event makes the occurrence of the second event more likely. Is the second event more likely to occur if the first event has occurred? That's what a contingency is all about. So in operant conditioning, we'd say that there's a contingency between a behavior and a reinforcer if performing the behavior makes that reinforcer more likely to occur. If the animal's more likely to get the reinforcer after it performs the behavior than it is after it hasn't performed the behavior, then we'd say that that reinforcer is contingent upon that behavior. Okay? So it could be that if the behavior occurs, then the reinforcer occurs. And if the behavior doesn't occur, then the reinforcer doesn't occur. That could be the contingency, but it doesn't have to be. That's just one way that the reinforcer could be contingent on the behavior. But it doesn't have to be that there's a 100% chance of getting the reinforcer after the behavior and a 0% chance of getting it if the behavior doesn't happen. That would be the strongest contingency that we could have, but it's not the only one that we could have. Again, all that has to be true for a contingency to exist between the behavior and the reinforcer is that performing the behavior makes the reinforcer more likely to occur. Now, the importance of that contingency between the behavior and the reinforcer was demonstrated in a clever experiment by Lynn Hammond, which I want to tell you about now. Guys, this experiment involved 4 phases, and each phase was divided up into a series of 1 second intervals. Okay? So, during each 1 second interval, the animal is either going to perform the response or it's not going to perform the response. And it didn't matter how many responses the animal made during that interval, it was binary. These were rats in Skinner boxes. So they either pressed the bar during a certain interval or they didn't. Okay, so each phase is divided up into a series of 1 second intervals. During each interval, the animal is either going to perform that response, they're either going to press that bar, or they're not going to perform it. So, for the sake of simplicity, if a rat did press the bar during a certain interval, then I'll call that a response interval. And if they didn't press the bar during a certain interval, then I'll call that a no response interval. Okay. Now, the reinforcer in this study was water. The rats were somewhat water deprived during this experiment, so water was highly reinforcing for them. And as you can see in this little table that I've made here, the probability of getting water after a response interval was always the same. It was always 5%. So across all 4 phases, the rats always had a 5% chance of getting a little water after each interval that they pressed the bar during. But what Hammond manipulated was the probability that the rats would get water after a no response interval. Now, in phase 1 and phase 3, that probability was 0%. So, in those 2 phases, the animals had no chance at all of receiving water if they didn't make a response, but they had a 5% chance of receiving water if they did make a response. So, in other words, in those 2 phases, the reinforcer, the water, was contingent upon the response because performing the response, pressing the bar in this case, made that reinforcer, it made that water more likely to occur. It increased the probability of getting water by 5%. So we do have a contingency here between the response and the reinforcer in phase 1 and phase 3, but in phase 2 and phase 4, there was no such contingency in place because in those 2 phases, the animals were equally likely to receive water regardless of whether they made a response or not. So as you can see in the table, during those 2 phases, the rats still had a 5% chance of getting water if they pressed the bar, but they also had a 5% chance of getting water even if they didn't press the bar. So during those 2 phases, performing the response did not increase the likelihood that the reinforcer would occur. And so that's why I say that there's no contingency here between the response and the reinforcer during those 2 phases. Now, here are Hammond's results. We're looking at the rate of bar pressing here, right? Responses per hour. So how many times per hour are the rats pressing the bar? And as you can see, whenever that contingency was in place, whenever pressing the bar made water more likely to occur as a consequence, then we see the animals performing the response. They pressed the bar several thousand times per hour during those 2 phases where the reinforcer was contingent upon the response. But whenever Hammond removed that contingency, as he did during phase 2 and during phase 4, then the rate of responding dropped until the rats were making virtually no bar presses at all. And so, guys, this is pretty strong evidence that animals are sensitive to how their actions affect the likelihood, how they affect the probability of certain outcomes. So, when pressing that bar ceased to be instrumental in producing the water, when that response no longer made that consequence more likely to occur, when that contingency no longer existed, those rats stopped performing the behavior. So contingencies matter. It matters whether the reinforcer is actually contingent upon the response that you're trying to reinforce. And we also need to consider the role that an animal's evolved behavioral tendencies can play in operant conditioning. Because those evolved tendencies can make it so that acquiring a certain response is either more difficult or less difficult, depending on what the behavior is and what reinforcer it produces as a consequence. So, for example, let's say that we have two pigeons here, and we're going to try to train each of these pigeons to do something for food. So, for this pigeon, we're going to train it to flap its wings for food. And for this one, we're going to train it to peck at something, like, say, a disc on the floor or on the wall. Okay? So, food is the reinforcer here for both of these pigeons, but this one has to flap its wings to get the food, and this one has to peck something with its beak to get the food. So, question is, which pigeon do you think will have an easier time with? Which of these behaviors will be easier to train? Will it be easier to teach this pigeon to flap its wings for food? Or will it be easier to teach this pigeon to peck for food? We'll probably have an easier time training the pecking response, right? Because food is the reinforcer here, and pigeons just naturally peck at stuff to get food. So, by teaching this pigeon to peck for food, we're teaching it to do something that's consistent with its instincts. I mean, it just has a natural tendency to do that anyway. But wing flapping isn't something that pigeons normally do to get food. Rather, that's something that pigeons normally do to get away from things, to escape from things that scare them or harm them. So, if we hadn't used food, if we had used something like, say, the termination of an electric shock, if we had used that negative reinforcer, if we had administered shocks to these pigeons until they either pecked with their beaks or flapped their wings, then we'd probably have an easier time training the wing flapping response. Again, because of what the animal instinctively wants to do anyway. It's more instinctive for pigeons to flap their wings to get away from something painful than it is for them to peck to get away from something painful. So they'll learn to associate that wing flapping response with the termination of shock more readily than they'll learn to associate the pecking response with the termination of shock. Okay? So contingencies matter, instincts matter. And finally, guys, one last factor in operant conditioning that I want to mention here is what your textbook refers to as motivating operations, which are defined as anything that changes the effectiveness of a particular consequence. So those are called motivating operations, and there are two basic kinds of motivating operations. Establishing operations are those that increase the effectiveness of a particular consequence, and abolishing operations are those that decrease that effectiveness. So, for example, one type of establishing operation would be deprivation, right? I mean, if one animal has been deprived of food and another one hasn't, then food will be a more reinforcing consequence for the deprived animal than it will be for the non deprived animal. And as a result, the animal who is deprived of food will probably learn faster. Food will be a more effective reinforcer for it than it will be for the animal that wasn't deprived of food. So, deprivation is a good example of an establishing operation. And a similar example of an establishing operation would be the effect that eating salty food has on the reinforcing value of water. So, if I've just eaten a whole bag of salty potato chips and you haven't, then water will probably be more reinforcing for me than it will be for you, right? And so, if we're both learning to do something that produces water as a consequence, then all else equal, chances are that I will learn that behavior more quickly than you will because I'll be more motivated to learn it. That reinforcer will be more valuable to me in my current state than it will be to you in your current state. However, let's say that instead of eating a bag of salty potato chips, I had instead just polished off an entire gallon of water, and then you and I both learned to do something that produced water as a consequence. In that case, you would probably learn the task faster than I would. You'd certainly be more motivated than I would be because I'd be satiated on water. right? And that satiation would act as an abolishing operation, which again is anything that tends to undermine the power of a reinforcer. An abolishing operation is anything that makes that reinforcer less effective. So the point is, in addition to the reinforcer itself, another thing that matters when it comes to the effectiveness of operant conditioning is the animal's motivational state when that reinforcer is delivered, because these motivating operations can make the same reinforcer more effective or less effective for any particular animal. Okay, well, like I said before, there are several other variables that can also influence operant conditioning, and I'll just leave you to read about those on your own in the textbook. But again, as always, if you do find yourself with questions about anything you've read in the book or anything you've heard in one of these video lectures, then please let me know and I'll try to get things cleared up for you. That's going to do it for this video lecture, though. So I'll catch you next time. Take care.